right, so 2-1C is on proportional relationships as linear relationships. Okay, so continuing to talk about y over x. And the unit rate, we're always trying to figure out how much is in one. So 1x, right? So we're usually trying to figure out this number up here on top. So it says two cousins, Grace and Kelly, are both headed to the same summer camp. They leave their houses for camp at the same time, but the graph below represents the girls' trips to camp. So as you look at this, I see time and I see hours. I see time and I see hours. So it says analyze the graphs to determine which of the girls is traveling faster. Well, here's my x, here's my y. So I know distance was my y over time is my x. So if I look at this, they want me to look at my friend Grace. Well, it says here, time 0. If Grace hasn't left yet, that means she hasn't gone anywhere. So y over x would be 0 divided by 0, which is just 0. Here they say in 1 hour, Grace is 60 miles from our house. Name that movie. Anyone? Name that movie? Grace. No? Okay. If you know the movie, you know what I'm referring to. You've never seen? Okay. I might be too old. Okay. So now, 60 miles in 1 hour. Okay, so that'd be 60 over 1, which is 60. Okay, for this next one, I'm going to go to 2 hours. 2 hours is 120. Well, I know that because it says my distance on the y is 120. So I'm just looking at my graph for Grace, and it says 2. Okay, which means now I need to go to 3 hours. At 3 hours, how far has she gone? Well, 180. Well, I know that makes sense because if I do 120 divided by 2, I get 60. If I do 180 divided by 3, I get 60. Well, what do you think this pattern's going to be? If I have 240 for my distance, Grace is right here. How many hours is she at? Well, 4. Okay, 240 divided by 4 is 60. What does that mean? Her unit rate, she goes 60 miles an hour. Well, what about Kelly? When Kelly hasn't left her house, where is Kelly at on my distance? Well, Kelly's already at 80. What does that mean? My y over x is still 0. Kelly, when she's at 120, Kelly's like right here. What does that mean? Kelly's actually at probably like, let's just say 0.75 when she's at 120. Okay, hours 0.75. So that'd be 120 over 0.75, which is, when I simplify, 160. Okay, at 2 hours, Kelly is at 200. So when I divide my y over my x, 200 divided by 2, I'm at 100. Well, when Kelly is at 200, we know she's at 2 hours. Okay, same thing. When Kelly's at 4 hours, Kelly is somewhere way up here. She's probably at like 300. So what do you notice about these? These numbers over here on the right are not going up at a constant. They don't form a proportion. No proportion, and the reason why is because it does not start at the origin. So what do you notice about y over x for Grace? Grace is proportional. Ooh, let's get right. Grace is proportional, all right, G, is proportional. She starts in the origin, or starts at 0, 0, and goes up by 60 each time. Okay, Kelly, she is not proportional because her graph starts at 0, 80, right? She starts at 80 on the y-intercept. So it's not proportional. Describe why Kelly's driving relationship is not proportional. Doesn't go through 0, 0. Okay, is it possible to still describe the rate at which Kelly drives? If so, what is it? she's still going right up the same rate as our friend Grace. She's just starting farther from home or closer to our destination. So yes, she is still going at the same speed, which starts at 80 or at 0.80. Okay. Often the rate at which a relationship changes is known as the rate of change, your unit rate. Both of the relationships described above have a constant rate of 60. This constancy defines them as linear relationships. Okay, use what you've learned above to see and write an equation that represents each girl's distance y from their house. Well, Grace starts at 0 or 0, and she moves 60 miles an hour. Our friend Kelly starts at 80 on the y-intercept, and she also moves 60 miles an hour. Okay, so next to the x, that's usually your unit rate. That's something called slope, okay, or the rate of change that we're going to talk about. And then these variables over here to the right is where you're starting on the y-intercept. For number 2, it says our friend Agatha makes $26 for selling 13 bags of popcorn. So 26 over 13. $26 for 13 bags of popcorn. Find and describe the rate of change of this relationship. Well, if I divide 26 by 13 to get 1 bag of popcorn, how much would it cost? Well, $2. Complete the table that shows the amount of money Agatha makes for selling up to 3 bags of popcorn. Well, if Agatha doesn't sell any popcorn, she makes $0. If Agatha sells 1 bag of popcorn, she makes $2. If Agatha sells 2 bags, she makes 4, and 3 bags, she makes 6. So this might be bags and then money. So when I label this, I'll have bags on my x-axis and money made on the y. So if she doesn't sell anything, she's at 0, 0. I'm going to go up by ones here and maybe ones here. 1, 2, 3, 4, 5, 6. Okay. So if she sells 1 bag of popcorn, she makes $2. 2 bags of popcorn, she makes 4. 3 bags of popcorn, she makes 6. When I graph this, it goes up at a constant. Highlight in the graph where you can see the rate of change. Well, right here, for 2 bags, it's 1. So there's my rate of change. Notice how it's still going up at the same amount each time. Write an equation that represents the relationship between the number of bags of popcorn she sells, x, and how much money she makes. Well, what's my rate of change? Each time, to get my outcome or my amount of money, I take the number of bags she sells and multiply it by 2. So I get y equals 2x. At a different fair, somebody gets paid $8 a day plus $2 for every bag of popcorn he sells. Find and describe the rate of change. Okay, so x is bags, y is money. So if our friend Fitz doesn't sell any bags, he still got paid $8 for that day. If Fitz sells 1 bag, he still got his $8 for that day, but he got an extra $2 for selling that popcorn, which is 10. If our friend Finn, or Fitz, not Finn, Fitz, sells 2, he gets 12. 3, he'll get 14 because he automatically has that $8 just for the day. So graph this relationship on the same coordinate plane. Well, if I come up here, Fitz, no matter what, still makes $8 through his company. If he sells 1 bag, he's at 10. 2 bags, he's at 12. So what do you notice about these? Is Fitz's graph proportional? No, his graph is not proportional. But I can still see the rate of change is still changing the same amount, but he's going to get more money than Agatha because he's starting with that $8. So write an equation that represents the relationship of Fitz selling and the amount of money he makes. Well, no matter what, his total money, we're going to put his rate of change here, but the difference is we're trying to figure out what goes here. Where does he start on his y-axis? No matter what, he makes $8 a day. But then from there, every 2 bags or a bag of popcorn he sells, he makes $2. So we get y equals 2x plus 8. Okay, write at least 2 sentences explaining the similarities and differences. Well, Agatha, you know what? Let's start with similarities. They both get 2 books for $2 a bag they sell, right? However, Agatha, call her Ag for short, only starts with $0 in her account, and Fitz gets paid $8 for being. So what I'm going to have you guys do is do the homework down below. I want you guys to do number 1. Just do number 1 because that's all I have right now. So do number 1, and then we will go over the rest of this in class tomorrow. Come to office hours if you need me.